Hi, I'm Richard.
Richard is a senior product manager on the Autodesk Fusion team, and he is currently looking after the Constrain components functionality in Fusion. We've got a question here around mates versus joints. So this is from our forum, and this user, he's looking for a good example of joints in Fusion that function like mates. Can you give us some clarity there?
Let's off the bat go. When this question was posted, we hadn't yet released constraints. So as of today, being the 30th of July, there are currently two methodologies for connecting components in Fusion. One of them is joints, which we have had from the inception of Fusion, and we've got the newly released constraints. So let's go over some real basics, how they are, how they work, where they both live together, and how they might compare to tools that you're used to in other CAD systems. So these are all the different types of joints that you can make. And one of the key things with joints is you're describing its position and its degrees of freedom in two simple clicks. So that's done by what we call joint snaps. And let's create one here. So we're going to find this rigid joint. So I'm just going to find that in the browser so I can delete it. And I'm going to drag it out of its captive block there. We're going to go up and we're going to go joint. And I'm going to choose a snap point on the component first, which will be the center bottom there. And then I'm going to choose a snap point, which is the center bottom there. So that's defined the location of where both of those two components connect together. I have the ability to do some adjustments and some offsets if needed in X, Y, and Z and a rotation around Z. And then most importantly, in the motion category over here, I have the ability to choose a motion. So I have the ability to go through and choose, do I want this to have any motion or do I want it to be rigid? So rigid says it on the tin. It will hold it rigid in place. There are no motion. And then the motion is everything we see below. So if I just go OK now, we have a slider, for example, here, which allows it to move along 1 degree of freedom. We have planar. So this allows translation in 2 directions and then also rotation about another one. So we can also rotate around the one that's locked as well. So I think that's actually, when you really speak to people, that's where a lot of the confusion comes, is in that planar joint. Revolute, as you'd expect, something that revolves, but hasn't got any linear movement anywhere. It's just a revolute. So you look at that wheel I've got there, it's held by 2 circlips either side. So it can't move. And that's what that revolute joint does. Cylindrical, revolves and moves. So that's, you got to think that's like a combination between revolute and slider. We've got pin slot there. I've then got a combination of planar and tangency. So planar will let it move and rotate, and then tangent holds it firm. I can't pull it out of that pin. Ball, as you'd expect, a nice little ball joint there. And what you'll see here is everything can be broken down into 6 degrees of freedom. You've got translation X, Y, and Z, rotation X, Y, and Z. Rigid have got none of them as degrees of freedom. So that's why it's rigid. Revolute's got 1, just around 1 axis. Cylindrical has got 2. All of this, just think about as those 6 degrees of freedom and how many of them are free. You're defining its location and its rotation or its degrees of freedom with 2 clicks. It is brilliant and it is fast if the snap points are in the right place. So if I've got snap points at either the edges or the center points, it is perfect for me. It gets a bit tricky if I haven't got snap points in those places. So let's go to this draw subassembly of this air fryer. The problem is I'm trying to assemble this front on here. And if I go to traditional joints, it's really hard because it's not actually there and there because there's an offset in the top. Again, I can't quite do that point with the one in here because they're not actually perfectly touching. But what I can do is start to use constraints and build up my relationship. So rather than having to define everything in 2 clicks, I can build up the relationship of that curved face with that one. I can add another constraint. And I can add that one to that one. And then finally, let's go from there to there and put that offset in of 0.5. So what you can see there is I've made up a set of 3 individual constraints that fully define the location of those 2 objects to one another. So that's a little bit about how constraints work. And again, for anyone coming maybe from Inventor or SolidWorks, this will feel like a very familiar paradigm where you're building up those relationships. And again, one of the key things here is you can choose what tool works best for you. Can you really easily define a square peg in a square hole with snaps? Well, to be honest, joints are probably going to be a nice solution for you. Or have you got more complex geometry like this, where you need to really start building up those relationships by things that are touching? So that was our brief overview of joints versus constraints. The key thing with joints is you're defining the location and the movement in 2 clicks. Works brilliantly if you have those 2 clicks. If you don't and you need to build up the relationships over multiple pieces of geometry, that's where you're going to go to constraints. I'm not the one there to tell you what you should use. Everything's a tool in the toolbox. You can use a spanner as a hammer if you really have to. Now, the final one is a bit of a wild card I've thrown in. Ground to parent is not a joint or a constraint. What it actually is a way of holding something free in CAD space. If I middle click and move that around now, I am not moving the CAD. I'm moving my perspective of it. If I zoom out, the CAD isn't going, I'm going further away. You're like a camera looking at this. And when I move this around, the CAD is not moving. I'm the one that's moving, looking around this. So what you need to make sure is when you have your design, if I unground to parent that anchor and I unground to parent my base plate on there, what I can do now is actually drag this around. So you can see I'm actually moving around now the part, which we don't want. We very rarely want things floating in space. And that's where ground to parent comes in. So ground to parent means I can actually lock something down to its parent. So I'm locking that component to the parent component.